Congruent triangles. What do you think congruent triangles are? So let's say triangles that are the same shape and size. Now, what determines the shape of a triangle, do you think? Its angles. What determines its size? Yeah, think about it. Those sides get bigger as the triangle gets bigger. And if it's the same shape, the angles will stay the same. So in essence, we could kind of infer from this that congruent triangles have the same what? Angles and what? They're not exactly the same because they're different, but they're the same measure. Okay? And what you're going to find is we're not saying all the angles are the same. We're saying the ones that are copies of the other. I'm going to do my best to draw two congruent triangles. Okay, they're probably not exactly the same, but they're pretty close. First thing I'm going to talk about is what is called a congruency statement. They must be written in corresponding order. So, our example here. I'm telling you to write this in corresponding order. What do you think we mean by corresponding? Huh? We said that the angles are the what? Angles and sides are the same, right? So wouldn't correspond probably mean write them in the same order? In other words, the angles or points that correspond? If we're just going to drink that coffee, we're not going to have it either. So I'm going to say that these two triangles are congruent. What order do you think I should write them in? I'll let you in a little secret. The first one you write, it doesn't matter what order you write it. How about we write A, B, C? Now, when we write the second one, when I'm saying corresponding order, what do you think needs to correspond to what? Well, I mean, if I wrote the A first, what corresponds to the A, you think? Yeah. Another way to think of corresponding is basically, isn't this just like a turned copy of this one, if they're congruent? So what's the copy of A? Sometimes it's obvious, sometimes it's not. It's D. And this one's kind of obvious, isn't it? What's the copy of B? What's the copy of C? This is written properly. I could have said triangle BAC would be congruent to triangle what? What's another way to write this? You guys try to do that on your own, see if you get it right. Try to finish out that congruency statement that I wrote, see if you get it right. And then I'll tell you the correct answer. I have to start with the angle that corresponds to B. That would be angle E. Then I went to A. So what corresponds to A? D. Then I went to C. What corresponds to C? That would work as well. So you guys understand writing in corresponding order. What would be an incorrect one? Let's see, if I said triangle CBA is congruent to triangle, well, I could say FDE. Is that correct? C does, no, don't write it down, just look up here. Does C correspond to F? Does B correspond to D? No. That's incorrect. That could be a multiple choice answer on an EOI test or a test I give. They could have both of these on there. And while you may think that that's right because it's using the same three letters, it's not. It has to be written in corresponding order. You don't, if a congruency statement is written properly, you don't even need a picture to tell me what's congruent to what. Now, next thing we're going to talk about is this, CPCTC, which means corresponding parts of congruent triangles are always congruent. CPCTC. When we do a couple proofs from this chapter, a lot of times your reasoning will be CPCTC. Corresponding parts of congruent triangles are always congruent. Just bring it to me. Thank you. Next time I have them bring it in because I'll tell them they're absent. All right. What are the corresponding parts of my congruent triangle here? Well, you have the angles. Tell me what's congruent. What's congruent to angle A? Angle D. Next one is what? Angle B. What is it congruent to? Last one, angle C is congruent to angle what? the sides that are congruent. What side do you want to start with? Well, if you look at your statement here, we can start with side what? A to what? B. Segment AB is congruent to segment what? Questions there? Well, look, A to B, now what? BC is congruent, segment BC is congruent to segment, EF. And the last one, a segment AC is congruent to segment what? We'll go with DF, since we're writing them in the same order. By saying triangle ABC is congruent to triangle DEF, I say all of this. Does that concept make sense of them being congruent? That makes sense that if the triangles are congruent, wouldn't their parts also be congruent? So it is important that we understand that I didn't even need this picture to write these statements. Everyone look up here. Since I know it's in corresponding order, I know A has to be congruent to what? D. B has to be congruent to the second one over here, which is? And C would have to be congruent to the third one over here, which is? And then I know that A to B makes a segment or a side, right? AB would have to be congruent to the same first two over here, which is what? DE. BC would have to be congruent to what? EF. And AC, first and last, would have to be congruent to what? First and last. You see how I don't even need a picture? Right now, to prove two triangles congruent, you need all of this. We're going to learn some shortcuts in the next sections. Get out your workbook pages. Starting on 47, wants us to show that all polygons by identifying the corresponding parts, then write the congruency statement. They've already identified the corresponding parts for me, have they not? J congruent to what? T. P congruent to? L congruent to? So can I write a proper congruency statement here? All you have to do is write one in one order. What order do you want me to write this in? So triangle JPL, and we put a triangle in front of it, is congruent to triangle. What has to be, if J's first, what has to be first for the other triangle? T, and then what? And then, as long as they correspond, you can do it any way you want. Give me another, what's another example? Triangle what? LJP would be congruent to triangle what? Easy peasy, huh? Number two, I'd like you to look at this one. This is something you're going to use a lot. And in the proofs that we do, which we are going to do some proofs for 244 and 45, this side DF is what is called a common side. Why do you think it's called a common side? This is a side for triangle DGF, and it's also a side for triangle what? DEF, right? So when you mark them, sometimes you make that the third mark, so you see it. So to write a proper congruency statement, it would be triangle what? I'm going to go with DEF is congruent to triangle. Nope. Look at this now. I started with D. It's how many marks is the D? So which one is its copy? D, right? D, and then I went from the 1 mark to the what? So I need to go from the 1 mark here to the what? So what would be next? G. And then what's next? F. Whenever you're confused, go by the marks, okay? When you have them written down. Any questions there? See, these are kind of tough as far as corresponding. Why? Does this angle really look different than that angle? Not much, huh? Now, here it says find the value of x and find the value of y. And they tell that these two triangles are what? So, this is congruent to this is congruent to that, and let's say that is congruent to what? That. So what is angle D equal to? What is y equal to? That was easy. Well, what's 2x minus y equal to? Well, we don't know this one yet, but can we find it? How can I find this angle? What do we know about it? What did we learn in the last section? Wake up. Mr. Taylor. Dylan. Wake up. You don't get to go to sleep either. Sit up, please. What is 108 plus 48? 156. So I've used 156 degrees up of all, it's like saying you have 100, inside a triangle, you got three, let's say there are 3 billfolds or 3 pockets, and you have $180 that fill up these 3 pockets, right? You've used 156 of it. How much is left for this third angle? Huh? 24 degrees, correct? Because this plus this plus this, always inside a triangle has to add to 180 degrees. So, what does 2x minus y have to equal? 24 degrees. But I have 2 variables here. But what can I find the other? I already know that y is equal to what? So 2x minus what is equal to? So what would I do next? I don't want to know. I want to get my variable terms on one side, everything else on the other. I don't want negative 48 to be there. What could I add to it to make it disappear? A positive 48. That would make it 0 and leave me with just 2x over here. But what allows me to do that? If I add 48 over here, I have to what? I have to always keep an equation balanced. So this is 72, is that correct? I don't want to know what 2 x's are equal to. I want to know what one of these x's are equal to. How do I make a 2 into a 1? Divide by itself. If I divide everything on the left side by 2, I have to divide what? Everything on the right side by 2. 72 divided by 2 is? And they ask us, let's look again. We are supposed to find the value of x, which we found to be what? 36. And the value of y, which we found to be? We're going to do, and this may be different, in fact I'm pretty sure it's going to be different than Canvas, so I'll have to change it. 1 and 2, 4 through 7, (9 through 16), and 18 through 20. Guys, a lot of these have equations. You had better write the problems. You had better draw the figures, and you had better show all steps and work. If not, I will not even consider it. Okay? I have cut the assignment down. Purposely. The pictures do not have to be works of art, but they do have to be labeled. You have homework tonight. This is due at the end of the hour tomorrow. EO8s, that's what's on Canvas now. That means what? End of the hour. Any questions on any of that? Let's get to work.